You're listening to Don't Waste Water.
You do see a lot of other people involved in this field who you will see them say, oh, these are the normal contaminants. We're just going to use industry standard processes to deal with them. And whilst on the face of it, that is true, the practical reality of that is it's still quite complicated and challenging to figure it out. And you have to figure it out before you get commercial.
Hello, bonjour, and welcome to the Don't Waste Water podcast.
The other aspect was the size of the resource is also fundamental. And certainly the scale of the Smackover, I think, is completely unparalleled, more or less anywhere else on the planet.
I'm your host, Antoine Walter, and in today's episode, I'm delighted to welcome Andy Robinson as my guest.
At the start, I think would be very open. It was, let's throw everything against the wall and see what sticks, because there are so many different ways that you can think about selectively extracting lithium from a continuous brine stream.
Andy is the president and COO of Standard Lithium.
The difference between running processes in a laboratory to then actually running a real continuous process with the real brine that you're going to be processing in the commercial plant, those are night and day. They genuinely are.
Standard Lithium coins itself America's 21st century lithium company, and indeed, they shall become the first lithium developer in the world to produce direct extracted lithium at a commercial scale in El Dorado. It's now several weeks that we're exploring together the depth of the lithium world, and we've heard quite a lot of things about direct lithium extraction, or DLE. For instance, we've heard from Chris Moreno, the very recently appointed CEO of Vulcan Energy Resources, how
DLE, or the DLS, the absorption has been around for a long time commercially. In fact, at the moment, as we understand it, absorption accounts for 10% of the lithium supply globally. So that definitely, underneath the DLE umbrella, is commercial.
And yet, you've heard many of my other guests on that microphone discuss with me how DLE is not yet commercial and might be the next big thing, assuming it gets to that commercial scale. So where's the truth? Well, everybody's right here. What Chris Moreno refers to is that in Argentina and China, companies have been using DLE as one step of the lithium extraction process while still leveraging evaporation ponds as a sequel step. What's still not reached yet, though, is a company or process that would be leveraging DLE and getting rid of evaporation ponds. And that is the game changer that would unlock many more geographies and resources across the world, hence the legit excitement around it. Now, excitement often comes as well with wide-ranging creativity, and right now, the DLE scene is blessed with blossoming companies trying out a wide range of technologies. And let's face it, it's also because of that the lithium field is so thrilling for a water nerd like me. But before further exploring these technical takes, I thought it would be worth following Ben Sparrow and Robert Mintak's advice and getting Andy Robinson on the microphone. Why so? Well, because if Standard Lithium is set to be the first company in the world to bring DLE to the commercial scale without any evaporation ponds, it's probably because of him. As you'll hear in a minute, he won't admit it and he'll refer to luck as Robert Mintak did before him. But still, from picking the right place to go all in on DLE, to testing out a bunch of processes from lab to demo scale continuously over the past 3 years, to the next steps on the horizon from lithium carbonate to hydroxide conversion and to carbon capture, it takes a sound methodology and a cool head approach, which can probably inspire many in that field. So without further ado, let me leave the floor to Andy to explore his 5-step rule for a good lithium project and learn from his learnings in El Dorado. Remember though, if you like what you hear, please take this episode and share it with a friend, a colleague, your boss or your team, and I'll meet you on the other side.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi, Andy. Welcome to the show.
Thank you, Antoine. Pleasure to be here.
I cracked you the secret a bit before starting, you have been warmly recommended by two of my very recent guests. So I have high expectations for today's discussion, and I'm pretty sure you will be able to outperform those expectations. So before I jump straight into the topic, let me start with my opening tradition, which is the postcard. What can you tell me about the place you're at, which I would ignore by now?
I am currently located in Vancouver, in North Vancouver, which is a lovely part of the world. I'm not from here originally. I am an Englishman by birth, but I've lived here in Vancouver now with my wife and family for 17 years. We're long-time residents here and still love coming back home to Vancouver every time I travel to various parts of the world. It's an amazing part of the world to come back to.
Well, I told you that you came in warmly recommended. Let me just let you listen to what Robert Mintak told me.
My associate, Dr. Andy Robinson, he's probably, if not in the top two on the direct lithium extraction globally.
So how does one get in the top two in lithium extraction globally?
Hard work and time served, to be honest, Antoine. I've been working with Robert now since 2014, so we have a long track record. And through that entire history of working in the lithium industry, we've been solely focused on using modern extraction processing techniques to get lithium out of an existing resource that is being processed and developed using conventional brine evaporation techniques. So that was in the Clayton Valley in Nevada in the US. And then since 2017 onwards, working in the Smackover Formation in Arkansas and more recently in Texas to trying, testing, breaking every single type of lithium extraction technology that's available, creating our own, using other people's, etc. And really just spending the time, the bench scale in the laboratory, literally sort of test tube, beaker scale, right the way through to where we are right now, which is a very large demonstration plant, which runs 24/7 in Arkansas, and just about to moving towards commercialization, like making it even bigger again yet. I would argue with Robert whether I'm one of the experts. We've just been lucky. We've surrounded ourselves with really smart people. They've done all the hard work. I just get to tell people about the work that they've done, frankly.
That's an interesting pattern. I think Robert mentioned 15 or 20 times during my conversation with him how lucky he's been. So maybe you're very lucky, the two of you, or maybe there's a bit more than luck involved in what you're developing in El Dorado. I'm really looking forward to dive a bit deeper into that. Before, I've listened to your appearance on Joe Lowry's podcast, and I'm a water guy, so I had to get myself educated to this lithium word. So Joe Lowry has been my primary source of getting that starting point in understanding the lithium. And he keeps repeating that lithium is not a commodity. It's a specialty chemical, and it is a very special field. So what's your position there in the sense of really breaking new grounds? You might be leveraging stuff which exists for a while in terms of mining, exploration, stuff like that, but you're also creating a full new category within all of that.
Yeah, I mean, the lithium world is a very rapidly evolving industry. For many decades, it was a very niche industry with a very small number of players, and processing techniques and the products that they made were very carefully tailored. The entire industry is undergoing a revolution, frankly, in terms of the amount of lithium which will need to be produced over the next several decades to enable electrification and energy transition story, which is happening around the globe. And the role of suppliers such as ourselves, the Standard Lithium, and the people who will use the lithium products that we will be making, that's also going to need to evolve, Antoine. The types of materials that we will make from the lithium contained within the Smackover Formation in Arkansas and Texas, that's going to be used to fuel an entire new generation of vehicles, stationary storage facilities, etc. And so Joe is absolutely correct that lithium currently is not a fungible good. It's not an instantly tradable commodity. It is still very much a material is made by a producer, and then it is qualified and used by an end user in their particular process, whether they're making cathode materials or whatever they're using the lithium chemicals for. So there is still very much a buyer-seller relationship, which is not there in a normal sort of commodity type relationship. But it will evolve. I'm not going to sit here and try and predict where that relationship will sit in 5 years' time or 10 years' time, other than say our function as Standard Lithium is to find resources, build the technology to extract those resources and turn them into a very high purity end product that potentially can be sold to multiple different eventual consumers of that product. There's a long way to go, Antoine. In the industry as a whole, it will evolve and develop over the next few decades for sure.
You mentioned your project in the Smackover formation. If I'm right, you're the person who pointed that place and said, that's where we have to go. So what indicated you that was the best place to start that journey? And what were you looking for? What were these indicators which put you on the way?
There's a couple of key things there. One is clearly indication of grade. So whilst you're right, we're a water processing business, it still has to have a mining mentality. And as with almost everything in mining, grade is king. The concentration of the thing that you want to get out of the stuff that surrounds it is still extremely important because it's a very fundamental lever on the economics of extracting that particular material. So grade is very important. And there was a wealth of historical data throughout the Smackover Formation that pointed towards a very significant lithium grade contained within the brines. So there was enough data there to point that, okay, grade looks to be very favorable there. The other aspect, and again, I think this kind of came from Robert's and mine experience working in the Clayton Valley in Nevada, was the size of the resource is also fundamental. A very small, high-grade resource could be good, but it's not a great story to tell when you're trying to build a large company like Robert's and mine's job and ambition is to build a very large lithium producing company for the North American market. And so you need a very large resource. And certainly the scale of the Smackover, I think, is completely unparalleled, more or less anywhere else on the planet. To the best of my knowledge, it truly is a gargantuan resource. The other thing then is a little bit more arcane and a bit more technical, which is I've spent a large amount of my sort of professional career working in and around groundwater resources. And so I always, whenever I think about how to envisage a fluid-based resource, I always, given a preference, would want it to be in a porous media formation rather than a fractured media formation. That means the distribution of the resource, the way it which behaves when you induce a pressure gradient on it, when you try and pump it or put it back into the formation. In a porous media, it's much more predictable. You can understand how it will behave over not just days and years, but decades and centuries potentially. And the Smackover Formation, again, is geologically fantastic in that regard because in the key horizon, it's almost a perfect eolitic limestone. It's just this beautiful, granular, porous medium that behaves very predictably. And therefore, when we think about resources, it's much easier to understand and to predict its behavior. So those are some of the aspects. As a project developer, we always think about permitting, stakeholder approval, how receptive are the people who live in the area and actually own the resources? How amenable are they going to be to people turning up from Canada, particularly people with funny accents like mine, saying, hey, we'd like to do something in your backyard? And Southern Arkansas and East Texas certainly tick the boxes there for us as places they're certainly open to resource extraction and processing type industries because there's so much of that goes on there. And then one of the reasons that we also kind of ended up where we did was that there's this amazing history of brine processing in the area in Southern Arkansas. There's this hidden industry that even most people in Arkansas have no idea is actually there. But, 40% of the world's bromine comes from the Smackover Formation brines. And so there's this very well-established regulatory environment where it's well understood that you can drill a well into this formation. You can pump a brine solution to the surface. You can extract a mineral. Historically, in the case, it's been a bromide ion has been removed to make elemental bromine. And then you can put that same bromine-less or bromide-less brine back into the formation again. And they've been doing that for 6 decades. So it lends, there's a very high degree of stakeholder and regulatory support where people are just familiar with the concept that, oh yeah, you're going to pump something out, extract some value from it and put it back where it came from. Yeah, we're good with that. Lots of those aspects came together in the Smackover Formation. That was really what drew me there. And when we formed the company and got it going, that was front and center of where we wanted to be. And I'm still very excited to be there for sure.
If I get you right, that ticks 5 boxes. You have grade of the resource, you have the size of the resource, which is huge. You have the fact that you understand the underground and that it's a porous material, which gives you a good understanding of how it flows underground. You have the permitting, which is especially in LANXESS or dissolved because they are extracting that brine, which also links to number 5, which is this processing of the brine already happening. So you have all that context to extract lithium, but at that stage, you're still not extracting anything. You're just taking boxes. So what I'm interested is, how do you go to the next step, which is, I guess, I'm not a big specialist, but in Arkansas, it was pretty impossible to have evaporation ponds.
Yes.
So that was lending itself to DLE.
Absolutely, yeah.
But how do you pick the type of DLE which you ended up developing?
Yeah. This is also one of the central tenets of when we formed the company. So yeah, you really nicely laid out sort of those 5 key factors when we think as a project developer, like as a lithium project developer, what do we want to see there? But when we think about the DLE technology, the philosophy was always not, I know the best technology, like I have found an amazing DLE technology and I'm going to make it fit in the Smackover formation. It was always very much, okay, first of all, we're always going to work with real brines. I'm never going to do the work with synthetic solutions. And we will effectively, at the start, I think would be very open. It was, let's throw everything against the wall and see what sticks, because there are so many different ways that you can think about selectively extracting lithium from a continuous brine stream. And so we honed in, we tried lots of things and lots of things worked. You can get a lot right. You can make almost anything work at a bench scale. So almost all technologies look fantastic on the bench scale for the most part. But we applied a critical eye to those ones. We found ones which seemed particularly well suited to the Smackover formation brines. And then we adapted, adopted, optimized, and de-risked. So we went through multiple technologies which looked to work. We then started to scale, test them at larger scale, and we kept an open mind all the way throughout. And that really was the process that we went through. And the key thing for us, Antoine, is that DLE is really just a name, a philosophy given to what's being contemplated in lithium extraction. Really, what we're doing is continuous chemical processing. DLE, in my mind, encompasses absolutely the entire flow sheet, frankly. In a lot of sort of DLE providers, it's just kind of one unit operation inside a multiple unit operation flow sheet. In my mind, it's an integrated chemical process from the start to the finish. And that's been very much the attitude that we take. And that's why we spent, frankly, a lot of money, of our shareholders' money, when we designed and built this large demonstration plant and installed it in El Dorado. It was a relatively aggressive, bold move on our part. We spent a lot of the money that we had available to us as Standard Lithium at the time to do that, but it was absolutely so that we could try to integrate a continuous flow sheet at that plant using real brine every single second of the day. And maybe we'll get into this a little bit better, but the difference between running processes in a laboratory, even when you sort of do some scale up, or in a 40-foot CCAN somewhere where you might run a process for a week or two and then you'll swap over your feed, etc., to then actually running a real continuous process with the real brine that you're going to be processing in the commercial plant. Those are night and day. They genuinely are. There's a lot of learning that takes place in those smaller piloting type operations. Not to say they're not worthwhile, but the difference in learning and understanding between those sort of smaller, more discrete batch processing style operations versus running something and running millions of liters of brine through it on a continuous basis. And that's real brine, which varies. Natural feedstocks vary over time. Like you see changes even at a coarse scale. They look very similar. You still see variations. And those all have processing implications, which are not always apparent when you're just running small amounts through for a kind of a short period of time.
There's one specific question I have on that part, which is this upscaling when you go from the pilot to the demonstration plant where you're running not at the commercial scale, but still continuous.
Yeah.
Is there an unexpected source of pain? I mean, You might be controlling the process, but all of a sudden there might be like a boring part, like ensuring that water flows.
Yeah.
That's not exactly what you would be looking for in a pilot, but still that's the hygienic factors, and maybe that might be on the critical path. I'm trying to find out what is the most unexpected, overlooked, touchy part, which can be troublesome when you go from pilot to demo.
Some of them are extremely mundane, and some of them are a little more chemistry focused. There's a whole series. Thinking about sort of the chemical side or the process side, those elements which are present at what would seem to be very small concentrations or very low concentrations can cause all sorts of unpleasant side effects in your process. And whilst they are not wholly unexpected, the way in which you actually have to deal with them is never the same. So they are the usual bad actors in any sort of water or brine processing operation. And they're the same things that cause all of the issues in produced water management at any oil field or gas field around the planet. But there are things such as silica, iron, manganese, sulfur compounds, etc. These things are present at low levels in almost every natural brine feedstock. And where you are running a continuous chemical process, they have an effect. And so understanding exactly what effect they will have, and it may not be on the lithium extraction part, it may be some other part of the flow sheet. Understanding the real effect of those is hard to estimate ahead of time and problematic and challenging to deal with to actually create a solution that will work at the commercial scale. Because again, these are things that you have to deal with on a continuous basis. They are always present and they are always slightly fluctuating, and therefore you need a flow sheet. And so you do see a lot of other people involved in this field who you'll see them say, oh, these are the normal contaminants. We're just going to use industry standard processes to deal with them. And whilst on the face of it, that is true, the practical reality of that is it's still quite complicated and challenging to figure it out. And you have to figure it out before you go commercial. Like, otherwise your plan will not work. So that's one of those sort of the chemistry aspects. On the sort of the more mundane side, managing suspended solids is always an issue. It, again, sounds incredibly simple and straightforward. Hey, you just filter it. It's not that simple and straightforward in the real world on a continuous basis. So that's always a challenge. And then one of the other aspects is whichever technology you would end up using, whichever combination of unit and process operations that form your flow sheet, there is a lot, because you're constantly processing a flow with changing chemistry all the way through your flow sheet. There's a lot of instrumentation, monitoring, and control. And you're in an aggressive environment, like you are dealing with a fairly hostile brine. And in our case, it's relatively straightforward in its chemistry, but you still have to control the process, and things like sensors, pumps, inline, online measurement, etc., all play a role in process control. And so building a robust flow sheet where the control systems don't get fouled, where you can control flow rates, pH, conductivity, turbidity, all of those things in real time, because you need to understand those things to build an operating chemical process. Those are also things that go wrong a lot. And so we've spent a lot of time figuring out, okay, what equipment actually works in this environment? And again, it's not what equipment works for a 2 or 3 week campaign of testing. It's what equipment works day in, day out for almost 3 years now. We've been really lucky, right? So because we are effectively piggybacked into Lanxess's operations, they have 6 decades of operational history in processing brines from the Smackover Formation for bromide to bromine conversion. So there's a lot of institutional knowledge there from the people who work on those facilities we've been able to benefit from as well. So we know what pumps work, we know what sensors work, et cetera, et cetera. We've been very fortunate to benefit from a bit of a brain trust in the existing brine processing industry in southern Arkansas.
It's funny because I can't tell you from the lithium end, I can tell you from the water and maybe dirty water end. Everybody always thinks it is possible to standardize and to have stuff which works like everywhere and to have industry standards. And then you figure out the hard way that it simply doesn't work that way, and that every single water matrix is specific and you need to adapt to that. So I guess if that's true for, generally speaking, slightly dirty waters, it might be even more true with quite complex matrices like the ones which you are leveraging there.
Absolutely.
You mentioned you threw everything against the wall and you saw what sticked. And you also said that actually a lot of it sticked. So you could have taken other processes, I guess you really chosen the best suited one,
Yeah.
which at the heart of it is an adsorption, and you're using, if I'm right, a ceramic adsorbent. How do you end up with that? What decided you for that? Is it strictly performance, or is there also an element of how reliable it is, how proven it is? And I was discussing, I don't know if they are your competitors, because it's really the other end of the word with Vulcan, which is developing this asset in Germany.
Yeah.
And they are leveraging a different type of adsorbent, more the Livent style adsorbent.
Yeah.
But they also patented their own version of the adsorbent, and they made it their proprietary process. Do you do something similar? And because that was only 7 questions, let me throw an 8th. Why?
Yeah, I mean, we've trialed and we've continued to evaluate other technologies in the demonstration plant, particularly the DLE core. And when we're selecting materials for use in the lithium extraction part, we are concerned with fouling. We're concerned with how the lithium selectivity over time is also extremely important, because one of the real benchmarks, if you like, of whether the process works is not necessarily the total capacity of the lithium adsorption on your material, but how selective it is versus all of the other materials that you do not wish to carry through your flow sheet. In our case, we're in a very calcic brine. The brine is hosted in the limestone, right? So we have a very calcic brine. So it is, how does the material select for lithium against calcium, against sodium, not just for 10 cycles, but for hundreds or thousands of cycles. And so because the material has to have longevity, every material that you select, and most of the materials that you looked at, whether they're proton activated, deactivated, whether they're elutimable materials like the Livent material, they all have fantastic performance out of the box. They all look amazing in the first few cycles. And then eventually you see capacity performance always asymptotes. There's just some sort of baseline performance over after 10, 100, 1,000, 2,000 cycles. And so you need to use a material which behaves the same in a predictable manner, because you have to run a chemical plant. At the commercial level, you need to have a process which basically does the same thing every minute of the day, because you need a team of operators to operate that. You can't have a team of 200 scientists constantly tweaking the process to make it work for the brine feedstock. You have to have a consistent brine coming into your plant, and you need a process that a team of operators can actually work. They can run the plant, and the process will not take care of itself, but it has to keep on doing the same thing day in, day out. You can't have something that works one day and then doesn't work the next. So the choice of material, that's certainly guided a lot by, does it work over the long term?
And so that ceramic adsorbent you're leveraging, is it yours? Or is it something you're taking from the market?
It's been leveraged off academic knowledge. We have made our own materials, and we've also been using materials which are available out of the market as well. So there's a kind of a combination which is in play at the plant. Yeah.
When I discussed with Ben Sparrow, he theorized that as generation 1 and generation 2. Generation 1 being the one which you can backwash with water, and generation 2 being the ones which you can backwash with acid. So you're generation 2. When I proposed that theory to Robert, he was a bit more nuanced.
Yeah.
So where would you sit?
Yeah, I'm not sure I'd fully buy into that, because I think the generation 1 materials, and I'll be clear, we've been trying and successfully also using some generation 1 type materials in the plant as well. Again, the difference between, like you were saying with regards to Vulcan, like using, as you describe it, a Livent-like material, which is a layered aluminium sort of hydroxide type material. That has been modified and adapted many times successfully over the last few decades. So I think there are now some very clever adaptations that have been made as to how that material is, the form factor, how it's packaged, like what resins it's kind of placed into, all of that. So the way in which it can be applied has certainly evolved and changed. And then again, with sort of the ceramic materials, like whether ours, we've been using a titanate-based material, and there are manganese-based materials, etc. They all have their strengths and weaknesses. I wouldn't say one is necessarily better than the other. The layered metallate structures, like the titanates and the manganates, certainly have higher capacity, but they have pluses and minuses as well. They're susceptible to pH degradation and long-term stability. They haven't been used commercially. So I certainly wouldn't say there's a Gen 1 and Gen 2. I think there's a series of materials that are available to the practitioner which fit in an integrated flow sheet for the brine chemistry that you're working with. I really don't think one is necessarily better than the other. And again, I'll take you right back to the start of the conversation, Antoine. It's like you need a large, consistent feedstock of brine, which just kind of has to look the same every day of the year. And you develop the right technology for that brine supply. And that's the approach that we've taken.
You've developed this right suited technology and this integrated flow chart, flow suit, flow process.
Yeah.
And that's your demo plant today, which is running since 2020, if I'm not mistaken.
Correct. Yeah.
You are setting yourself up for the full scale. What will change between your process today and the one you'll have in the full scale?
The only real change will be that in the full scale plant, there will be a recycle stream from the carbonation plant back into the front of the facility. That will probably be about the only major sort of, if you like, integrated flow sheet change relative to what's running in the plant right now. Because what we've got running in the plant basically is a small commercial facility, effectively. It's just we don't sell any of the products that we make. We just run it on a continuous basis to understand the process. But the change from the commercial plant, yeah, for the most part, it's just going to be more of the same. So it's going to mostly, we've tried to use vendor supplied equipment in the plant right now. We have tried to invent as little as possible, to be honest, so that we can buy the same equipment, just more of it for the commercial facility in the most part. And then, like I say, 1 or 2 recycle loops will be integrated into
What will you be recycling?
When you think about any sort of DLE process, you're spending a lot of equipment when you're building the commercial facility. It's an expensive business. So you are spending equipment to process all of that flow of water which comes into the front end of your plant. And obviously the scale of that flow is dependent upon lithium concentration. But you have to build, you're in the water business. If you think about the front end of one of these DLE plants, it looks a lot like a municipal water treatment facility. This is large, expensive infrastructure. These are big pipes, big pumps, big filters, big initial processing equipment, which is not cheap. And so therefore, there's a very large incentive to extract as much lithium as possible from your incoming flow. So therefore, when you sort of run through the flow sheet, there are always points where potentially you could lose lithium from the system, which would reduce your overall lithium extraction efficiency. And you want to keep that as high as possible. One of, if not one of the major, in any where you're taking a final solution, in our case, a mixed lithium sodium chloride solution, and you wish to carbonate it. In any carbonation crystallization system, there is always what's called blowdown, or there's always a bleed stream from that crystallizer system, which contains a relatively high proportion of lithium. So some of that you can put to other parts in the flow sheet, but there's typically always needs to be a recycle loop, which we can do really effectively in a DLE project. It's very difficult to do, for example, if you're doing your lithium concentration in the Atacama Desert, and then you're doing your carbonation and crystallization at the coast in Antofagasta, for example. Doing that recycle is not terribly efficient because there are hundreds of miles in the way, whereas we can actually recycle on a continuous basis at most optimal points in our flow sheet. So we can improve our overall lithium extraction efficiency from start to finish, which is a key metric for us.
And how much do you reach?
At the DLE stage, we see well over 90% extraction efficiency just in the DLE step. We actually see substantially more than that a lot of the time. And again, that's not just occasionally, that's over hundreds, thousands of cycles. Front to start, we're in the middle of the design phase for the commercial plant right now. So we have a contractor running what's called FEED, front-end engineering design study. I think the basis of design, we're working on a little over 88-ish 89% total start to finish extraction efficiency for lithium, which is huge. It's an incredible result, but is supported completely by what we see in the plant. So we're very comfortable with those sorts of overall efficiencies.
I just picked up a Muggle question on the way. So excuse me for really, I assume it's a Muggle question. I've been following Elon Musk's Twitter, and I've read that lithium producing companies are printing money, and you have a demo plant running since 2020 and you're not selling what you're producing. Why so?
Because, Frank, we're not allowed to at the moment. In Arkansas, And this really does vary from state to state within the US and obviously from country to country, but from state to state. The way that the business works in that area is that the minerals actually in the ground are owned by the mineral rights owners, which are individuals, families, companies in some cases who own those rights under the ground. And obviously they are due some money for when someone like us comes along, pumps that resource to the surface and creates value from it. Some portion must go to the people who actually own the minerals, the mineral rights owners. There's a very well-established framework for that for bromine in the state of Arkansas. There is an established royalty type structure for other minerals. One for lithium has not been established yet. It's in the process of being established. Until that is finalized, we can't sell the product because right now there's no way that we can then effectively provide the financial feedback to the mineral rights owners.
So right now we discussed your extraction process. You have a brine at the entry, which you run 1, 2, 3 times, depending on how it drops out. You get this 88% extraction over the entire process, might be even north of 90%, which is really impressive.
Yeah.
That is all set up. You have this feed study done by Koch Engineering, if I'm right, which is ongoing, which is going for this full scale. And you could be stopping there and you could be producing lithium, and that would be already a significant step forward for that industry worldwide and in North America. But you're not stopping there. You have pilots ongoing. You are looking at conversion from lithium chloride to hydroxide.
Correct.
You're looking at carbon capture. I mean, conversion, I would expect it to be maybe a more conventional pilot, like something which, I mean, would be rocket science to me, not rocket science to you. Carbon capture sounds like really next step in terms of what you try to achieve there. So why do you make your life so difficult?
Yeah, I mean, a great question. And the team might ask me the same question many days of the week as well. So, I mean, a couple of different things there. So one, again, sort of take you back to the start of the conversation. One of the reasons why we really like the Smackover is its scale. When I talk about the feedstock coming into the demonstration plant right now, the amazing thing is that when I move 30 miles to the west to our Southwest Arkansas project, or when I move another sort of distance over the state line into Texas to look at those, the feedstock looks basically the same. The brine composition and quality is effectively the same in all of those locations. The lithium grade improves significantly. So the quality of the resource improves as I move westward. But that means that we have effectively the development plan that we're working on and aim to execute over really the next decade is to get the first project built, scale, and then replicate across the same resource with effectively the same feedstock and the same technology to process the brine. But the conversion part on the end, that really does differ because there is definitely a market for both materials, whether it's lithium carbonate or whether it's lithium hydroxide. And certainly when we think about the North American automotive market, I'd say there's a slightly different psychology maybe than is present for some of the Asian sort of car manufacturers or for the European car manufacturers, where the concept of range and power density is maybe slightly more important in North America than elsewhere. So you're seeing certainly amongst the larger automotive OEMs in North America, there's a little bit more emphasis maybe on those high nickel cathode materials to produce more energy dense batteries, better power generation, etc. And those all require a hydroxide product to create those high nickel cathode materials. So when we think about the development plans for the company, and we will need to have a range of offerings, so carbonate and hydroxide for sure. The carbon capture one that was just one of those sort of slightly serendipitous instances where we were introduced to the technology, which is developed out of Norway, and it's a membrane-based technology. We use a lot of membranes in our plant. There's a very high degree of comfort with membrane technology amongst our technical team. And one thing, whenever you are running a crystallization business, which we will have to use, we're going to have to crystallize products, you will always end up burning natural gas somewhere in your flow sheet. So you will always be generating CO2 emissions from what we are going to build over the next few years. And so the concept of being able to use a novel technology, which offered really kind of interesting and compelling economics, both in terms of capital pricing and operational pricing, to capture carbon dioxide out of natural gas burning flue gas emissions using a membrane technology. It seemed like a good fit. And yeah, we've been fascinated to try it. And we're also fascinated with the role of carbon dioxide in everything that we do. So we haven't actually talked about this, but we've been doing some really interesting work using carbon dioxide as a reagent to help with some of the flow sheet work. So kind of looking to consume CO2 as a reagent in our existing flow sheet. So sort of beneficial reuse of captured CO2 in the flow sheet. But then also, as we kind of scale out across the Smackover Formation, there's an enormous geological permanent sequestration facility, basically. And we will be moving more fluid in and out of that formation once we're at full production than anyone else in the entire region. So the ability to capture CO2, use it in our flow sheet, and then permanently sequester it where it could be into that geological formation seems like a very compelling story to me and to Robert as well. That's the future. That's the future just embodied in everything that we want to do there. We want to make responsible lithium chemicals to go into the energy transition story. And if at the same time we can capture CO2 from anything that we do, and then ultimately put any additional captured CO2, maybe using that aqualung membrane technology back into a permanent geological sequestration reservoir, seems like a fantastic story. So it really all fits together from my point of view.
I think it absolutely fits together. It's with this over-delivering. You could be just producing lithium and that would be fine. But in terms of ESG impact, in terms of positive impact all the way through the chain, especially if you can leverage the CO2 in your process, it's like a win-win. Pretty fascinating, and that's an understatement. You mentioned at the very beginning of this conversation how you want to build a very large company. And with the Smackover Formation, you probably have everything it needs to build that very large company because you have Arkansas, you have Texas, you have lots of resources. Yet, let's assume a crazy French guy comes to you with water samples, right. and those happen to be lithium rich. I have 2 water samples with me, one at 310 ppm of lithium, the other at 430 ppm of lithium. Of course, it's not just lithium and water. There's a lot of other stuff inside. Is that something you would straight away wipe off the table? Because crazy people which come with crazy ideas, you must have that twice a week, if not twice a day. Or are we speaking here of something which might eventually be interesting to you?
Yeah, I mean, I would say that it would depend. Clearly, if you kind of go back to the start of the conversation, some of those sort of the 5 things that we sort of think about when we think about scale is key. So the size of the formation or the brine resource that's there is really important. Those concentrations are absolutely economic. Those are certainly would justify additional investigation. Yeah, for sure. Whenever I look at those, if it's less than 150 ppm lithium, I would always say that's going to be a struggle to ever make the economics truly work. Now, future lithium pricing, who knows, right? So there's certainly many things there which are to be determined and which could make a lot of marginal projects very attractive potentially in the future. But certainly those numbers that you're talking about there, yeah, that's a resource which should be looked at some more. For sure.
Let me try to follow your 5-step framework. Actually, there's one of the steps where I don't have the answer, but for the others, I have it. Grades is what I just mentioned. We are above the threshold 150 you just gave, so I guess it doesn't speak too bad. Size, I don't know. That's the one I don't have. I just know it's part of a big aquifer, and I'm working with geologists I'm still running a podcast and still not a serious project, but I want to do the thought exercise up to the end. Yeah. And geologists have been looking into it, so maybe they can give me the answer on the size, at least to have an estimate. In terms of porous media formation, the underground is very well known and is a porous material, which is documented for decades and centuries. It has been like the region which was transitioning from France to Germany several times over history, and every country has been really mapping the underground. So that's known. The permitting is known as well because it used to be potash mining, and we would still be producing potash if the Australians would not be able to do it 3 times cheaper. So, and there is no existing brine processing, but there are water treatments ongoing because there's also an underground landfill which burned, and which means that they are recycling the water to protect the rest of the aquifer. So there is an ongoing water recirculation, not to the scale we are discussing at LANXESS, really far away. So the thing I don't know is the size. From your experience, aside from answering the question of the size, where shall I start?
I mean, the place to start would be to trial some initial DLE technologies again at the bench scale and start using some available technologies where you can. There are a handful of vendors out there right now who have technology and packaged solutions that you could start to try, and you could understand initially lithium extraction potential from that brine. The scale item is very important. So understanding the extent of the formation, thickness, porosity, permeability, all of those items are very key. One of the things that I think we've been very fortunate from is that the Smackover formation, because it's been exploited for oil and gas for a century and for brine for 6 decades, there's a great deal of numerical modeling experience and reservoir engineering experience within that formation. And yeah, I would strongly recommend that you speak to a reservoir engineer or a hydrogeological modeler who could start to think about brine distribution, brine extent, flow boundaries, reservoir boundaries, etc., and how that might play into a resource understanding. One of the things that we have certainly come across is, yes, lots of oil and gas companies have come to us over the years and said, hey, I've got this field located just here, and we've got these lithium grades in the field, and we're making all of this produced water, which is a complete pain. It costs us money. Can we capture the lithium out of it? And there is still an order of magnitude difference between a commercial brine operation for lithium extraction and the volume of produced water, which is co-produced with oil and gas operations. A commercial brine processing business for a mineral extraction where the mineral is only present on a few, still in your case, 300 to 400 parts per million, you still have to process a lot of brine to make a commercial project. So the resource, the pore volume has to be large. It's very difficult to make anything work off a small sort of resource base.
Again, I had read that tweet from Elon Musk, so I was really thinking I was going to print money in the next month. So I was really happy you just...
Well, I wish you the very best of luck in printing money from it, Antoine. I certainly wouldn't begrudge you that.
Just to close that deep dive, by the way, thanks a lot for everything you shared and the openness in diving into your process and what you've been developing, which is truly amazing. If you have a threshold at 150 ppm where you say starting there, it starts to be interesting, does that mean that assuming you get Lanxess and your other Arkansas project up to commercial scale, would you be going into this additional fields, or do you really say we have this competitive edge of understanding the Smackover formation, let's triple down on it?
Yeah, I mean, I think certainly I would never say never. But the immediate focus of what we're doing is the nature of the opportunity, and the Smackover is huge. So it is a truly world-class resource of a scale which I don't think is really matched anywhere else. Not that I've found anyway. I could absolutely be proven wrong, but not from the basis of my research over the years. I've not found anything similar scale, grade, quality anywhere else on the planet for lithium. There's so much ahead of us that as a company, and as we grow and we add people and we continue to build out our capabilities in terms of designing, scaling, building project 1, then project 2, 3, 4, 5. There's so much ahead of us in the Smackover. It's difficult for me to say with a straight face, we should absolutely be chasing other formations right now. But we will see. Like, the lithium demand curve is much discussed, and structural deficit of lithium chemicals by the end of this decade is certainly seems to be a potential reality. And who knows what incentives that may generate for a company such as ours to scale more quickly and in other jurisdictions, in other resources. Certainly, whilst it's not in our immediate game plan in a year, 2, 3 years' time, who knows, Antoine? This entire industry is just getting going. It's been a sleepy little niche business for 40 years, right? And it's just going through a revolution. And so how this business looks in 5-10 years' time, I think will be very different.
I just have one more, which I would sneak in with. So really, in 2 words, sorry. Is there a race going on to be the first one to be commercially producing lithium with a DLE process? Because everybody I met said you are supposed to be the number one. But Vulcan brought some doubt in my mind when I saw their calendar, because it seems like you will be producing at the same time.
We certainly hope to be the first new production in North America for lithium from brine, for sure. We feel comfortable with our timelines because, again, this is a project development. Permitting is always on the critical path for most projects. It's the bit that doesn't get talked about. Like, On a water podcast, there's an emphasis on the water and the technology and the processing. But as a project developer, permitting, stakeholder approval, stakeholder buy-in, state and local government approval, and the permitting that fits in and around all of that story is at least as important. One of the amazing things about what we're doing in South Arkansas is that there's such a high level of support for what we do because we're effectively building inside the fence of an existing processing facility. Our permitting requirements are minimal because we're using the same infrastructure that's already in place. And so there's just some small permits that are relating to our process only, but there are no impacts. We don't have to drill any wells. We don't have to put any pipelines in or any of that. I would say I have a very good degree of certainty around some of my timelines because I know I don't need permitting or agencies or authorities to approve certain things before I can do certain other things. So I'm comfortable with our timelines. But I mean, we need all the lithium that we can get, frankly. So, I mean, whilst I'd love to win the race, as long as we're soon, that's good enough.
Well, Andy, I opened saying that I had high expectations because you've been warmly recommended twice and you over-delivered on those expectations. So thanks a lot for that. To round off, I just have very rapid-fire questions, short questions aiming for short answers. I'll try not to sidetrack. Still French, I can't promise, but I'll try.
It's time for the rapid fire questions.
My first rapid fire question is, what is the most exciting project you've been working on and why?
Honestly, everything that we do in Standard Lithium, I mean, like building the plant that we've got even running right now is just still completely exciting whenever I go around there and see what we're doing. It's amazing. Thinking about building the first one and like selling a ton of lithium carbonate to an end user and it going into a battery and going into an EV, that would be amazing. That would be a fantastic achievement. Be so proud of when we do that. But I'm very lucky. I have a very interesting job and everything that we do is pretty cool. Even my kids think it's okay, right? Yeah.
Can you name one thing that you've learned the hard way?
Working continuously with natural brine. That's been a headache. Yeah. We predicted how lots of things would work, and I would say none of those predictions played out. Everything worked differently than we thought it would do. And so that's been a really hard lesson. This stuff is difficult. It seems really simple. Again, goes back to continuous chemical processing is, whilst a lot of it is very simple, the chemistry should be very straightforward. The practical reality is difficult to get right. And so that we've learned the hard way. But me personally, I think some members of the team who know better than I do and are not quite as optimistic as I am probably knew. But I've certainly learned that the hard way.
Is there something you are doing today in your job which you will not be doing in 10 years?
I mean, other than using AI to write news releases, which I still have to do right now. To keep it on message for your podcast, I think we spend a lot of time taking discrete samples and sending them internally to a lab for analysis. In the future, I think we'll see a lot more inline, real-time analysis of fluid streams and the control of the process from that inline real-time analytical tools. So I think that process analytic control through real-time chemical analysis, that will be something that we will do in the future that we can't quite do yet.
So here I have to prevent myself very strongly to open a sidetrack because I can start another hour if I do.
Okay.
It's a fascinating field, really fascinating field. So maybe you have to come back at some point.
Sure. I'll bring somebody else on with me who knows a lot more about it, frankly. Yeah.
What is the trend to watch out for in the DLE sector?
Oh, I don't know if there's a specific trend, to be honest, Antoine. I think it's for people who are truly interested, I think again, I'll hark back. It's people actually telling the full story about their entire flow sheet from start to finish. I think that's going to be that's the real interesting thing that investors in the space, people who just have an intellectual interest in what we're doing, that is the trend to figure out and understand, like, what does the whole flow sheet look like and what seems to be working across multiple different formations from resource to resource, because I think that tells you a lot.
Last question. Would you have someone to recommend me that I should definitely invite as soon as possible on that microphone?
I mean, if you wish to know about lithium, you should absolutely speak to Mr. Lithium, to Joe Larry. He would be an excellent podcast guest because he's forgotten more about lithium than most of us know. So that's just a fantastic person to talk to about how the industry has evolved and where it's going. And if you want to know about process analytic control and modern approaches to processing, you should speak to a friend of mine and a colleague of mine, Professor Jason Hein, who is at the University of British Columbia and also at Telescope Innovations. So he's an individual who we use a lot to lean on as a technical resource. Probably, actually, no, without doubt, the cleverest person I've ever met, an incredible individual. So either of those people would be fantastic podcast guests.
Thanks a lot for the recommendation. I have been exchanging with Joe. I have not been able to pin him down to having on the microphone, but I will keep on trying because, yeah, I got the recommendation from others. And Robert advised me also to speak to Jason Hein. So,
there you go.
Two recommendations, which is the magical number which brought you on that microphone. So it was a good pattern to reproduce. Thanks a lot for the time you spent with me. Sorry, I was French and I took more time than expected. If people want to follow up with you, what's the best place for them to contact you?
I mean, really through the Standard Lithium website, or I can always be emailed at a.robinson@standardlithium.com. And always happy to interact with people who are interested. And thank you. Fascinating interview, and it's a pleasure to speak with you, Antoine, truly.
Again, my pleasure. So thanks a lot. And I stand my point. If you want to be back at some point, for instance, when your plant starts operating, I'd be happy to have you to discuss what you learned in the start.
We should have a live podcast from the facility, and then we can actually run you through in real time.
Sounds good.
A lithium ion entering the plant and finishing up in a 100 micron particle of lithium carbonate.
Well, a live podcast from the facility is definitely something I'd be interested to share with you, so I'll be following Standard Lithium's path for sure. And you know what's the best way for you to ensure you don't miss it the day that one is out? Exactly, it's to subscribe to this podcast. So just hit the subscribe button wherever you're catching this one up, and I'll see you next week.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.